Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is maximum subarray. So we are given with an integer array nums, and we have to find subarray with the largest sum, and we have to return its sum. So it's a medium level problem. So let's understand this problem more clearly with the help of example. That we are given an input nums like -2, 1, -3, and so on till 4. We have to find the largest sum. We have to find a subarray with the largest sum, and we have to return its sum. So for this array, the sum with largest sum, the subarray with the largest sum is 4 till 4 minus 1, 2, and 1, and its sum is 6. So let's see how we can achieve this problem. So we will so first way is to do via brute force. Like we select -2, uh, like we do for loop uh, in 2 iterations, 2 pass, double for loop. So the outer for loop will start from one element, like we started from -2. It will keep let me write it down. So we select this one, and we'll keep adding the elements uh, one by one by one by one by one, and we'll store the maximum. We'll compare the maximum at each iteration, and whatever the maximum for this one iteration, we'll store in the max. Again, we'll select this one and do the sum for rest of the elements. Again, I'll select this one and do the uh, sum of the elements. So in this way, it will be n square approach. So can we do in lower time complexity? Yes, we can do on O of n using cadence algorithm. So what is cadence algorithm? So important points of cadence algorithm, or you can say important uh, notes. That first we will maintain two pointers. First is current sum, and is maximum sum till here, and the second point is whenever current sum is less than 0, we'll make current sum equal to 0. These are the two key principles of cadence algorithm. Mainly second one, first one is like for the pointers. So let's understand with an help of example. So we'll start with -2. Sorry, we'll start with -2 in the sense we'll initialize our current sum equal to -2 and max here as -2. So for -2, so this we will create. So let's maintain our current sum here, and this will be representing. So let me clear this so that it's better readable. Let me clear this as well. Okay, so as I said, we will maintain current sum and max here. So one important point, as I said, current sum is smaller than 0, we'll change current sum to 0. Now we will initialize -2 and -2 with current sum and max here. What is our next element? Next element is 1. So important rule, as I said, whenever the current sum is less than 0, we'll change our current sum equal to 0. Now we will consider this as 0 because it's less than 0. Okay, so let me add setting. Yeah, now we will add. Now as I said, it's smaller than 0, so we will consider it as 0. Now 0 plus 1, current sum becomes 1, and the max here was -2, and the current sum is 1. We'll take the maximum of, so maximum of max here comma current sum. So maximum of max here and current sum is 1, so we'll keep 1 here. Now we'll see another element, that is -3. So for -3, the current sum was 1, so 1 minus 3, that it will become -2, and the max here was 1. We'll compare max here with the current sum, that is max here is 1 and current sum is -2, so we'll keep our max here as it is. Now the next element is 4. So as I said, now again if you see, the current sum has become negative, so we'll consider it as 0, or we will change it to 0. Now we will add the current sum to the next element, that is 4. So 0 plus 4 will become 4. Now we will compare the max here with the current sum. So the maximum of current sum and max here is 4, so we'll change our max here from 1 to 4. The next element is -1, so 4 minus 1, 3. Whether max here is, the current sum is greater than max here? No, it's not, so we'll keep our max here as is. Now adding 3 plus 2, that will give us 5. So is it greater than max here? Yes, it is greater than, so we'll update our max here to 5. Now 5 plus 1, 6. Is it greater than the max here? Yes, we'll update 6. Now we will add the current sum till here to we'll add our current sum, that is 6 minus 5, that this will give me 1. So is it greater than max here? No, so we'll keep 6. 1 plus 4, again the last element, will give us 5. Is it greater than the max here? No, so we'll keep our max here as is. And now the max here will give us the maximum length of the subarray, or not the maximum length, the maximum sum subarray. So yeah, that's Kadan's algorithm. Now let's see the code part of it. So here, as I said, we will initialize max here and current sum as the initial element, and we will iterate from I is equal to 1. So here, as I said, important point, whenever the current sum is less than 0, we'll change our current sum to 0. Then we will add current sum to the next element, and we will check whether the max here, previous max here, is greater than or smaller. So we'll take the maximum of both current sum and the max here, and whatever the output is, we'll put it in the max here. And finally, when the loop is over, we'll return max here. So let's run this program. Okay, so the test cases are passing, so it means the program is running fine. So I hope you like this video, and for more such videos, please share and subscribe. It will keep me motivated to present you with more such videos and more such algorithms and data structures. Thank you.